Right. Hi everybody, this is Amula Naresh. Getting back to our continuous topic, let us continue the topic. In the last class, in the last video, we have learned regarding what is Lorentz and Drude's theory and what is voltage, that is potential difference, and what is electric current. So in this class, we will learn regarding what is EMF, that is electromotive force, what is the resistance, and what is Ohm's law. Right. So firstly, coming to the EMF. Guys, you know very well EMF is something which is related to battery. But EMF is quite similar to voltage, that is potential difference. As you know, EMF's units are also volts. It is also measured with a device called voltmeter. But the difference is EMF is considered to a battery, whereas voltage is considered to any current carrying conductor. Now today we will discuss regarding what is the main difference between voltage and EMF. Right. EMF, which is an abbreviation of electromotive force, is a property, physical property of a battery in which we determine the work done by chemical force. Whereas in the voltage, it is defined as work done by the electric force to move a unit charge from one end of the terminal to another end of the wire or conductor. But whereas if you go to the EMF, that is electromotive force, it can be discussed as the amount of work done by chemical force, because all the batteries nowadays are made up of chemicals. You know, most of them are made up of chemicals, either voltaic or photovoltaic or any other type of cells which have chemicals in them. They will be having two electrodes, that is, one is cathode and another is anode. The positive one is called as anode, whereas the negative one is called as cathode, because they cathode and anode are the two different electrodes of a battery. Now whatever the ionized ions are generated in the liquid, the electrolyte which is present in the battery will be either acid or any other which can ionize easily. So in this, when the battery is ionized, when the electrolyte is ionized, two different ions can be liberated. Either positive ions are called as cations, whereas negative ions are called as anions. These liberated ions have to move from the liberated place to the terminals of the battery, and the work done to move the ions which are generated from one terminal of the battery to another terminal of the battery is called as electromotive force, that is EMF, and its unit are also volts. So EMF can be calculated with the help of, it can be measured with the help of a device called as voltmeter, and voltmeter should be parallel, connected in a parallel circuit, parallel connection to measure either EMF or voltage. Right guys, this is regarding the EMF and voltage. Now we will learn what is resistance. Resistance is something which is quite natural. This word is very familiar to everybody, because we know that when we want to oppose something, it is called as resistance. We know that when we move a force which is resistance towards our movement is called as friction. When we move forward on a bicycle, we know very well it takes a lot of difficulty, it takes a lot of strength, it takes a lot of effort to move forward. That is because there is gravitational force as well as there is another force which stops the movement of our bicycle, and that is called as frictional force. So resistance is something, resistance is a property which stops the flow or which opposes the flow of anything. Here we will learn about electric resistance. Electric resistance is a property which stops or which opposes the flow of electrons in a conductor, flow of charge in a conductor, and this resistance is directly proportional to the length of the conductor. Right, this resistance can be denoted by letter capital R, whereas its units are ohms. This resistance is a property which depends upon the length of the wire or any conductor. It depends the area of cross section of the wire or any conductor. So let us know how does resistance depend upon length and how it depends upon area of cross section. We know very well that, let us consider a point, let us consider a path where there is a path of straw. If you need to drink some juice, if you need to intake some juice with the help of straw, if the straw is longer, it takes a lot of time for the juice to enter into your mouth. That means if the length is more, the resistance is also more. That means if the length increases, resistance also increases. This is something similar to electric resistance also. If the length of the wire is more, then that wire will be offering you more resistance. If the length of the wire is less, it will be offering you least resistance. That means the resistance is directly proportional to the length of the wire. If you go to the area of cross section, we know the area covered by the conductor is called as its cross sectional area, and this cross sectional area, if it is more, the number of electrons passing through that area will be more. If the area is less, the number of electrons or number of charges passing will be facing some difficulty to move through it. That is because if the area of cross section is more, resistance is less. If the area of cross section is less, then the resistance is more. That means it states that area of cross section is inversely proportional to the resistance, electric resistance of a material. By this we can say that resistance is directly proportional to the length of the wire and it is inversely proportional to the area of cross section of the wire. So if you remove the proportionality constant, you can write that R equals to rho into L by A. Rho here is the proportionality constant, which is the constant for universal constant for every material. Every material has its constant value. It is called as specific resistance or resistivity. Specific resistance is the amount of resistance offered by 1 meter length of any conductor. For example, 1 meter length of any iron wire, it has a resistance of 100 ohms. That means 2 meters will be having 200 ohms. 3 meters will be having 300 ohms. Specific resistance is the amount of resistance offered by 1 meter length of any conductor. It is called as a specific resistance. These resistance, by this we can now evaluate the formula of resistance. R is equals to rho into L by A. Right. Units of resistance are ohms, and this ohms resistance can be measured with the device called ohm meter. Nowadays we have ammeter, ohm meter, voltmeter, everything in a single device. It is called as multimeter, and multimeter is used to measure the different electric properties of a conductor. Right, this is regarding the resistance. We will come to know regarding what happens when resistors are connected in series and what happens when the resistors are connected in parallel. So a short note upon this is, when resistors are connected in series, that means the resultant resistance will be equal to the sum of all the resistors. That means if R1 plus R2 and R3 are connected in series connection, then the resultant resistance will be R1 plus R2 plus R3. Whereas if the resistors are connected in parallel, that means if they are connected in parallel, then the resultant resistance will be equal to the sum of the reciprocals of their resistance. That equals 1 by Req, that is reciprocal of resultant resistance, equals to 1 by R1 plus 1 by R2 plus 1 by R3. By this we can conclude that the resultant resistance of the resistors which are connected in series is more than the individual resistors, whereas the resultant resistance of the resistors which are connected in parallel is less than the every individual resistor. This is regarding the resistors, resistance, EMF and voltage. In the upcoming video we will discuss regarding our Kirchhoff's laws, Ohm's law and electric power. So if you like this video, please don't forget to subscribe my channel, and this is me, Amula Naresh, signing off. We'll meet in our next